All right, we have question 28. If f of x is that quotient, then the limit as x approaches -8 is. First thing I would do with this is factor out, or factor anything you can. Even if nothing cancels, at the very least, it's easier to plug in when you factor. So on the top, we have x plus 8 times x minus 3. On the bottom, we have x plus 8 and x plus 2. And lo and behold, x plus 8's go away. So we get f of x is x minus 3 over x minus 2. Now the limit becomes a plug-in problem because before, if I tried, I don't know why I'm writing infinity. It's -8. Before, if you tried plugging, I did it again. Before, if you tried plugging in, you would go 0 over 0. Oops, that should be a plus. So now we can plug in 8 minus 3 over 8 plus 2. We get 5 over 10, otherwise known as a half. And that's not right. So, back to the drawing board. What did I do wrong? Let's see. Oh, because it's -8. That would explain it. So, -8 minus 3 is -11. Over -8 plus 2 is -6. And that's 11 over 6. I was so convinced that was the answer since it was such a nice, neat fraction, but it wasn't. There we go. 28 is choice D. 29. We want to find the values of dy dx of this when y is 1. So first, we must differentiate both sides. So we have a mini little product rule here. I'm going to do that one in my head. I want the derivative first times the second plus the first times the derivative of the second plus 2y dy over dx is equal to 0. I'll move over the 2xy term. And so we'll get, and I'll factor out in one step. We could probably do that on this one. So we get dy over dx, x squared plus 2y equals -2xy, divided by x squared plus 2y. And so dy over dx is -2xy over x squared plus 2y. So now we have dy over dx is that. And we want to find out what this is when y is 1. So if you plug in 1, you'll realize we end up getting dy over dx when y is equal to 1 is equal to -2x over x squared plus 2, which begs the question, what is x? So we need to go back into the original and figure out what x would be. So I'm going to do that up here. If y is 1, we get x squared times 1 plus y squared, which is 1 squared, which is 1, equals 5. So x squared is equal to 4. So x is plus or minus 2, which, well, let's see if that affects the answer. So if x is positive 2, we would get -4 on the top, and we would get 6 on the bottom. So if x is positive 2, we get -2 times 2, which is -4, over 2 squared is 4 plus 2 is 6, which is -2/3. If x were to be -2, we would get a positive 4 on the top, and because of -2 squared being still positive 4, we get still a 6 on the bottom, which gives us 2/3. So we get two answers, -2/3 and +2/3, which would be choice D. Interesting. Number 30. We have ln of cosine of 3x. We want to take the derivative. So we have a double chain rule. So derivative ln of stuff is 1 over the stuff times the derivative of stuff, which is cosine of stuff, which is the derivative that is negative sine of stuff, times the derivative of the stuff, which is 3. So we get -3 sine 3x over cosine 3x. Now, since we have the same angle inside sine and cosine, we can simplify this to -3 tan 3x. Please don't divide the 3's. That's not correct, even though it's not a choice. That might be tempting to do. That's not correct, though. All right, number 31. If f of x is secant of 4x and f prime of pi over 16 is, well, again, we have a chain rule here. So f prime of x is, well, we have derivative of secant of stuff, which is secant of stuff times tangent of stuff times the derivative of the stuff, which is 4. So we end up with 4 secant of 4x tan of 4x. Now, if we're evaluating this at pi over 16, we would have 4 secant of what, tangent of what, is the question. I wouldn't plug this in. I would think about it. 4 times pi over 16 reduces to pi over 4, so we're really talking about 45 degrees here. So this requires our special rights, our 45, 45, 90 special right. The secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. This would be hypotenuse over adjacent, otherwise known as radical 2 over 1, or just radical 2. And tangent would be 1 over 1, hypotenuse, opposite over adjacent, so that's 1. So this just comes out to 4 radical 2. Not so bad. What do I say? I like that question. All right, number 32, another f of x plus h question. So again, the function is sine of x, which you might want to verify. X is 5 pi over 6. The sine of 5 pi over 6, 5 pi over 6 is 150 degrees, which has a reference angle of 30. So actually, we should probably draw this. If we're in quadrant 2 with an angle of 150, this guy is 30, so the reference angle is 30, and our reference triangle in this case would be -1, radical 3, and 2, if you do it that way. So f prime of x here is negative cosine of x. What am I doing? Sorry, just regular cosine of x. And then we're plugging in 5 pi over 6, as I said before, that's 150 degrees. Cosine of 5 pi over 6 would be, I'm sorry, my 5s are terrible. Let me redo that. That's not much better, but it'll work. Cosine of 5 pi over 6 is adjacent over hypotenuse, which is -1/2. And that's our answer. I like that one too. Number 33, given f and g are differentiable and they give you all these facts. They say h prime of x is f of g of x. They want us to find h prime of a. So h prime of x is f prime of stuff. We're using the chain rule here to differentiate times the derivative of the stuff. So now we end up getting we want h prime of a. So we're going to plug in wherever we see an x, we're going to plug in an a and see what this turns out to be. So f prime of g of a is c, times we have to evaluate g prime at a. So f prime at c is 6. So this is a 6. G prime at a is b. So we get 6b. They love types of questions like this on the AP. They try to give you all this extra info that you do not need. And they do that so that if you goof up the chain rule, that you will get an answer. That's not the correct answer, but you will get one of the choices. Number 34, finally, we'll be done with this. We're trying to graph the derivative. So if you think about what's happening here, real quick, we have a horizontal tangent at these points. As we get to this point, the derivative is positive, but decreasing. So our function is going to be above the x-axis, but going in down, a general direction of down. Then our derivative becomes negative and decreasing till you get to about here, about the y-axis, and then it starts to turn around, and then it comes back up. And this would be choice D. Now you got to be careful. D and C look very similar, but the problem is the maxes and mins on the original function, the place where the tangent line is horizontal, is happening at -2 and 2. So your roots for the derivative have to occur there as well. Don't get tripped up by that.